let's go. Funny game. Everything here is good. Looks good. How are things going? Hopefully audio's okay. Let's see. We have our documentation. What about technical design? Oh, this is this document. Do you have in source control this one? Okay. Okay. Alrighty. Getting the stream started. I hope anybody who's here had a good weekend. I'm not sure if anybody showed up yet. I'll just keep talking until then. Alrighty. I'm going to just get rid of this. Just talking about what we're doing today. Just taking a look at some stuff. Okay. Right now our input is handled in the main while loop of the project. The first thing I'm going to do is deal with storing input. Okay. Let's open up our technical design document here a little bit. Okay. The input. I'm going to start brainstorming here. I don't know who's here, but I'm just going to start just writing some stuff down as I'm talking before we actually start coding. So basic work, the basic flow of input is going to be like player input is pulled at the start of our game tick, whatever. We're going to have to store this in. So the change in input state needs to be stored in something which I don't know, needs to be stored somewhere. I'm going to say somewhere. That's generic enough. No, the basic idea is we're going to take the input from the platform level polling code and store it in some data structure, probably just an array, which we can read out in the game simulation. We're going to store input. We're to store input once per game update. This so basically we're gonna have input stored every frame, and we can reuse those inputs for like replays or for our network synchronization in the future. Yeah, it's the basic idea of it. So these stored input input commands. The input commands will drive character behavior. So you input A or B or whatever button, and you get an attack, or hold forward or back, your state machine will transition from walk. Transition from standing to walk and whatever. Okay. That's the basic idea. So for now, we're going to store input once per frame. I think we're going to get around to more optimized implementation, but for now, I'm going to go over just a little bit of what we did last time, just as a refresher. So we implemented the state machine processor thing, which handles state transitions, and this update state machine function. We call on end when transitioning out of a state, on start and transitioning into a new state, and we'll set the current state. And where's our update function? Oh, here it is. Yeah, so we call on update here. Cool, and then we did some tests to make sure all that stuff works. I think I can just run the test again to see that everything is still working properly before we get going. That seems to be the case. Yo, what's up, Mighty Sandwich? How you doing? Just getting started here. So, as I do as always, I like to start with our data. So we're going to need some kind of input command data structure. Could just use an array of bools or something like that, or a bit set, but just for now, well, actually, usually in C I would do something like a set of flags using enums. So yeah, let's just start with that kind of structure. Now, right now we don't have any input specific file, but okay, let's just start. It's a new file here. Let's call it input command. It's input.zig. Generic enough. Okay. And let's define our input data structure. Like a first pass could be something like input. It could be something like this, right? And where we just have like up, down, left, oh, not boo, bull, right, bull, and down, left, right, and let's say attack for now. We can change these things up. So this would be the easiest way to store our inputs. Just assign these bools values, and it should all just be false by default. Oops, I put commas here, didn't I? I'm just gonna like line this because I don't know why. Oh, yeah. I'll just leave it as is, sorry. Anyway, yeah, for now we could do something like that for input command data structure. So each frame would store a combination of these inputs, right? Okay. And then let's jump back into our game simulation. We need some data structure to store each frame's inputs. Well, I talked a little bit about our component system kind of layout. So almost all our data is going to be stored in what's called components, like this physics component. So let's introduce a new one called, well, first we need to import the input module. So let's just say input equals port.zig. They should work, hopefully. And then let's do this. So we're going to say input component equals new struct. For now, we're just going to store a single input on the current frame. We're going to need a buffer in the future, but we'll get to that at a certain point. For now, we're just going to do a base pass on our input controlling. So let's see. We'll just say we're going to have an array, okay? Because we want player 1, player 2, just as a demonstration. So let's do this. Just simple enough. This input command. I really need to be consistent with my naming scheme. Well, for the components, I'll stick with something like this. Okay. And then it's going to be an array, size 2 for the 2 players for now. And it's going to be an input command, right? And it's going to equal to default. I think that works. Okay. And so now we have this here. It's not, and we actually need to store it in the game state. So actually, let's not do it like this. Let's do it like each input component has one input command. Oops. And then I gotta mess that up. Yeah, it should be. And then we should do this. Yeah, input components. It's gonna be an input component. We need 2 of these for the 2 players. And I guess we have to initialize it. Okay, so we have our input components for the 2 players. Okay. And so we need to store things. We need some code to store things in these input components, and then we're going to read them to handle our game state. So let's start with storing things in the input component. Now, for now, we're going to do this in the main loop because we do have access to the game state right here. Okay. So let's do this. Right now we're pulling things like here, like pressing left, pressing right, pressing. But we're going to replace this with something like, just brainstorming real quick, like game state dot. Hold on. Game state dot input components. We're going to start with player 1 for now. And that's going to be like left equals true, right? Okay. It's going to be something like, we're going to get rid of this. Well, get to that. So let's just test this is working correctly real quick. And we're going to have to reset everything up here. So let's just make a convenience function real quick for the input stuff to reset everything. Can we do something like this, like function pug func, not func is fn, right? Reset void, and because my brain is not thinking too well right now, we need to have what is it? Self pointer to input command. And then we could probably just do this, right? We can do self equals input command to reset it back to defaults. I assume that'll work. Maybe it doesn't work. Expected. Oh, we need a comma here. Okay. Okay. Then he's a semicolon. Let's see. So we're gonna have to reset the inputs back to default values because each frame we need to make sure that input is either held or released. We're gonna assume it's released unless the input is held down still, which we check here. Okay. So we're gonna get rid of the pressing left and pressing right too, by the way. So reset input. Okay, so let's do this. We need to do input component 0 dot reset. Hopefully that works. Okay. Go ahead and just delete this. And then, yeah, we don't need any of this anymore. This is all my leftover C code from the past. We can just go ahead and do up, down, left, right here as well. Make sure I have controller plugged in. I do. Okay. Sorry, I'm not very energetic today. Still kind of, I don't know, allergies and stuff. Been pretty bad here. Okay, up, down, left, right. I think we're finally getting over the allergy season stuff, though. Okay, so up, down, left, right. It's all pulled. Okay, we're gonna handle this better in a bit by actually having index for all the input we're handling. But for now, this is just a prototype code. Then we'll come back and do things much more generically. Okay, so that's pulled. So we're just pressing left, pressing right. For now, we're just gonna for testing inputs. We're just gonna check this. Okay, and the question is, are we gonna compile? No, it didn't compile. Where's our error? You send a clarify input command at game simulation 13. Oh, is it not public? Oh, it needs to be public, right? Or something like that. Oops, where'd I messed up? Okay, it needs to be pub. Gotcha. Okay, I have to be explicit with exporting it, so. Oops. Okay, so it built. I messed up. What did I mess up? Use something to clear the input command. Input. Oh, yeah. Sorry. That's where I messed up. It should be input dot command. Gotcha. Because I imported it as input. Yeah. Oh, I didn't want to do zig test. Yeah. Starting the compiler does take a bit of time. Okay. Number name reset instruct input component. Oh, yeah. Sorry, I messed that up. It shouldn't be. So this is actually wrong. It needs to be input command dot reset. Okay. Dot input command dot up, and it's just to be everything here. Little verbose right now. We could fix that at a certain point, but let's get here and just for testing purposes do this for now. Oops. Okay. Did I start streaming? Oh, I did start streaming. My brain is not functioning very well this morning. Assigned to a constant. That doesn't work. Is there a way to make this not so this is acting as a constant in this context. Why? Like if we did it doesn't like this. Is it still going to take the same error? So it's treating self as a pointer, I guess, a constant pointer. That makes sense. So wait, I forgot how to dereference a pointer. Sorry, give me a second here. Jump back to the documentation. Or do I have it in my notes? Is it in my Zig notes maybe? Let me check. No, I didn't put the pointers in my Zig notes. Okay, let's jump to it. Dereferencing is dot star, right? Dot star, okay. So does that work for dereferencing a pointer? Okay, that works. Okay, cool. So it looks like our input does work. Left and right works. Fantastic. Okay, just to make sure we have those stored in our component. Okay, so we're going to actually move the thing that's controlling the character outside of this, right? Because we're doing all the input handling here. We need to do it in the game simulation. It needs to be part of the game character controller. Okay. The character controller is going to be part of the state machine update. So we need the thing we actually need to do now. Let me open up our like little tech design stuff. Okay. Character control. So the character will be controlled by a state machine with unique states for each action. State so state transitions will represent changes from one action to another. So basically, when you do like walking, you'll go from one state to the next. If you like go to attack, you'd go to attacking state, etc. So state. So player control player input will trigger state transitions to the desired action. So basically player will input something and that will trigger, there'll be some condition within the state to trigger the state change to state transition using player input. So far, what do we have? Under our action states, we have the state machine. So we need to implement a new, let's just do let's call this the character state machine. Our character states, let's just do character states for now. We might change it later. Okay. And we have the common state. Oh, we have the common states here. Right, we did have this. So we don't really need this for now. Let's go back to our common states. So we imported this for testing purposes, but we're going to have to implement, should we import the whole state machine? Oh yeah, we did have enums for these. Okay. Now I'm going to just add attack for, well, we might get back to attack for now. Okay, so I don't really, do we really need to import the whole state machine file into common states? No, we shouldn't have to do that. Okay, for now, let's just do this. So we have standing, but so these need to be aware, these states need to be aware of our input. So we're going to have to add the input to our context, the input command to our context. So if you saw previously, these functions have a context passed in, and then you have this combat state context. So what we're going to have to do is we either have to copy over the entire input command each frame, or we have a pointer. I'm very wary of having pointers, and if there might be a performance reason to do it, we'll use it. But for now, we're just going to copy over the input command. So what we'll do is we'll import input.zig. Okay. I don't know if these imports are relative to the folder in Zig or the top level directory, but we'll stick with this for now. And then in our context, we need to add input command. So I need to be consistent here. Anyway, input command is going to be a well, the problem is for now, let's just do input command, and it's just going to be equal to the default, which makes sense. Okay, and we're gonna have to somehow get this input command into the context. We'll deal with that in a bit, because we're gonna have to set up the state machine update within our game simulation, which we don't have there as well. So what's the first step? First step is we need to so we have a state machine here. Have we done any updates with it yet? No. So within our physics, why don't we have a while loop? Oh, okay. Okay, so if we look back at our technical code architecture, input handling happens first before the game simulation. But we have a command buffer update within the game simulation itself. This is done within our main game loop. So we could do something like this. Let's just get back here anyway. Okay, we'll just put it at the top for now. Well, where's our state machine update actually? Okay, it's right after the command buffer, which makes sense. Okay, so well, first of all, we need a state machine for each character. And if we look at our code for doing that, where was it? We made a test, right? We tested transitioning state machine. So we need to set up our state machine, right? With the context. Okay, so we need some kind of initialization step to do this. You see how like everything leads to another thing? You make high level plans and you have to like drill down until you finish each subcomponent. Man, I really need a lot more coffee. Okay, so far with our game state, we don't have any kind of initialization code other than the defaults that you see here. So let's just go ahead and make a function for initializing things we want. So for now, let's just call it init. And it needs to be void. And what we're going to have to do is we're going to have to initialize our state machine, which we don't have one yet. So let's just say, so what we're going to do, we're going to make the state machine's components for each player. So let's make another, and we're just going to make it the state machine as a property within the struct. So what's it? Did I import it as state machine? Yeah. So what do we need? We need the type of combat state machine processor. It's a type. Okay. And we need to assign a context like this. So, oops. sorry. It's dot context, right? The thing is, we don't have a pointer to the context yet, so I think what I want to do is I'm going to change the context to be something that's more dynamic, but for now, we actually can't do this, sorry. Can we do this? And then within our initialization function, we'll handle this stuff. So and for now, let's do let's do 10 like our physics component. I'm probably going to promote this to a constant. Well, I hope I'm not getting sick or anything. I am feeling a little weird. Okay. Let's see. What time is it, by the way? Okay, we've only been streaming 30 minutes. Okay, feels longer somehow. Okay, let's initialize it the same way as our physics component. And then, yeah, so within our init function, we're going to go ahead and just initialize 1. All right, hold on real quick. Also, we started with 5 entities right now. So we have 5 right now. By default. You know what? Let's just do 1. I'm going to get around to doing more in a bit. Okay. Is it just warm? No, it's not. Okay. Make some water, be right back. Okay, so we got our init function, and we need to set up a context. Well, a state machine is going to have a context for now. Again, we might make this a more of a dynamic thing we set up later, but let's make that equal to, what is it, the state machine dot combat context. That's it, right? Okay, and do we have to set up that in any special way? No, not right now. We have the test context, but okay. What is it not like here? Oh, no comma. Okay. So let's just set up our initial entity. So what do we need? Well, physics components are all kind of this like whatever. State machine, we're going to set up the first entity. So what do we have to do? We have to go to state machine components and first entity dot, oh, it's not going to figure that out for me. State machine dot context is going to have to be equal to the address of the context. Okay, so we have that set up. What else do we need to set up this thing? So in our test, we set up the context, blah, blah, blah. Oh yeah, so we're going to register our states. So let's do our first pass at this. We're probably going to make a separate utility function for handling this, but for now, So we can't, so these are going to be references. So we can't use local variables for this. So we're going to have to make it something persistent throughout the lifetime of the game. So we need some more persistent data for the character. That's not the components, but something that's just kind of, this is a common theme too. You like have maybe constant data you need to reference for a character, such as like all the properties for a move. So we're gonna have to move this out. But let's just register one state. Okay, just as a test. And let's move this out. We'll come back here and clean this up. Make this. We're gonna have to set up a place to store our like constant data. So, but for now, as a test, we're gonna set this up. I don't even know it's a var. Okay. So we have the dummy on standing. Oh, so the dummy. We don't want the dummy. What we want is to import the common states. So we have common states. Okay. And we have common states. So we need common states dot, well, what's in the common states? Oh, these don't take context yet, so we're gonna have to deal with that too. On start on end. Okay. Cool. Let's see. Is it really not filling this out for me? Hold on. Okay. Anyway, I'll have to do. Oh, it's because it's not pub. That's why. That's probably why it's not working. Okay, there we go. And then we'll have. And we need on start too. So on start equals common states dot standing dot on start. Okay, let's just format that a little bit. Okay. Okay. Alrighty, we're doing that. What's up, Caxips? Alrighty. So we got our standing callbacks here. And we're going to have to register it here. Again, this is just temporary, just to test this code. Okay. Got our standing callbacks. Got our context set up. We register our common states. What was the next thing we need to do in our test? So we're going to have to update the state machine. Okay. So oh, we forgot something though. Well, I forgot something. So we need to update these function signatures to actually work with our state machine because it takes a context, right? So yeah, so this need to take this. Oh, I'm gonna forget about this too. We don't have. We need to import. I'll move this context thing to another file. I'll just import this for now. I don't really don't want to have to import this for but is that right? Action states okay. And we're gonna have to change this to be. And did I export this? Make sure I exported this. Okay. So this needs to be pub, and this needs to be pub too, right? I think all this needs to be pub. Or is it not required? Oh, that means it's not required. I don't know. I'm just going to go ahead and do it. Okay. Public just exports the symbol. Okay. So you have access to another modules, other source files. Okay. We have like our test states here. Okay. Game simulation. We got initialization set. We're actually going to call init somewhere. So when we set up our state, game state.init, and we forgot something, didn't we? We need self. It needs to be a pointer to game state, and then the cell it has to be self. All these need to be self dot. These C++ habits I have left over. Okay, so we initialize the stuff so our state machine is registered and set up. This doesn't work like this. We need to be like this. Okay. It's pretty long. Okay. So we have state machine component, state machine registry, register common state. And then so we have a physics system. I'm going to add this action system, which will handle the state machine update. And we need a game state. We're just going to take that in for now. Game state. And we'll do something similar to this. We loop over all the entities. And what's going on here? Instead of being physics component, we're going to get this state machine components. We don't need to do this. We need to update the state machine instead. So component dot state machine dot let's update state machine. Yeah. And do we need to pass anything in? No, it's just the thing. Okay. So that seems right. But we're getting some error here. Oh, it seems to have void on this. Okay. Cool. And then we have the physics system. Let's update the action system first. So this should call the action system, which goes through all the entities and updates the state machine. The state machine does its thing, which updates all the states. Just a double check. It's going to get a context, and the context is set within the state machine itself for now. Yeah. And we just going back, we registered in the init function our initial test state. With the standing callbacks as the standing state. Cool. Looks good. Let's see. And try to build, see what happens. I'm sure there'll be an error. Probably forgot something obvious. Okay, what are we missing here? 18. So what did I do incorrectly? Oh, I don't need the semicolon. Okay. Use of undeclared something or another. Use of undeclared to enter combat state callbacks. What is it? Oh, and it needs to be state machine. Okay. Use of undeclared state machine components. Oh, yeah, it needs to be self. Okay. Okay. Let's do it again. Okay, another used to undeclared thing, combat state ID. That's going to be state machine. Okay. Oh, now we're getting a lot of errors. Unable to load, but the file not found. Oh, okay. Unused function parameter on start. Okay. So we're not using context in any of these functions. So, I guess import is relative to the directory in Zig. That's why we're getting this error in the state machine. Okay, that's fine. It should be, maybe that'll fix that. And then we can fix these errors in the common states. So I think it was like equals context fixes it. If memory serves me correctly. This discards the perimeter that we're not using yet. Hey, Melly Melon, stream is going pretty all right. Thanks for dropping by. Okay, unable load, state machine file not found. What's this at? On common states, okay. So it is relative, so I don't need this. Missing field context in the game simulation. Where is that at? 18. Missing field context. I have to state context. Oh, context is not a optional, is it? I did not make state the context optional, did I? Let's look at here. The context. Oh, it is optional. So, do I have to specify null? I mean, I thought I could do this null by default, right? Does that work? No member name state machine components instruct game simulation. Is it not exported? That's what's going on. Oh, that's my fault. Yeah, I should have stuck with. I should have really stuck with same naming scheme. What the heck? Oh, it's in this one. 39. Oh. Yeah, I really need to stick with the same capitalization scheme. Oh, cool. That's a good idea. That sounds awesome. Let me know how that goes. Like, I've used hacks in the past, and it was one of those languages I was really thought of using as kind of a, like, meta language to compile down to whatever. Well, the idea was, like, I wanted to have language which was agnostic between all the different platforms. Well, so that, like, maybe more future-proof, kind of. So, okay, if I don't want to use C++ anymore, whatever, I could switch to another language and use hacks to, like, generate that code in whatever language I want to use in the future. But hacks seems really cool. Okay, no member name context. No member name context. Really? Oh. Oh. There definitely is a context. No member name context instruct. Oh wait, I'm looking the wrong thing. Hold on. What am I missing here? Oh. Oh. So the state machine doesn't have component called context. Oh, it's capital context. That's why. Yeah, I should have stuck with the same. I think that naming scheme is completely isolated to this file, so I'm going to change it to something more consistent with the rest of the code. Error expected 2 arguments. Common states. Oh, right. Let's just... Well, let's do this. I think we have to do this. Oops. We have to give it defaults. That's interesting. We have to give it default argument list, even if there's nothing in it. We have to be explicit. I'm just going to comment these out for now. Might as well make it work, I guess, because we're going to test that here in a bit. Anyway, oops. So while we're here, optimize our work. Yeah, Hex has a lot of targets. It's really cool, though. Big fan. The type found const. Game simulation 40. What are we doing here? Expected type action state state machine callbacks found const. So okay, it's constant context. So for now, let's do var. We'll fix it here in a bit. That should be const. Okay, it does run. And we see state machine updates being called right here. Cool. So that works. Our state machine's running and running our state. So now we need to use the context to transition from standing to, say, walk. So how are we going to do that? Well, the idea is we're going to go to this. We're going to go to our on update and say if context dot input command dot let's say right is true, then we're going to transition. So for now, let's say equals true, and then context. This indicates we're going to transition, and we're going to say next state equals, what is it? State machine dot combat state ID dot walk, walking forward. Okay, and then we want to do something similar in our walking state. We don't have a walking forward, so we're going to have to register that first of all. Make it and register it. So let's just call it walking forward. And let's say walking forward on here just to say everything's kosher. And I'm just going to get rid of these update printing because it's very verbose. So walking forward on update, then on end, just so we can see this is working. Okay. So when we're not holding input command right, we'll return to state machine standing. Okay, so we got the transition to walking using input here, and then we got the transition out of walking back into standing. And we just need to register our walking forward state back in our game simulation. So fortunately, we have to do something like this again. And again, I want more persistent data storage for stuff like this somewhere, but we're not going to get there right now. And so walking forward. Doing this. Sorry, I'm moving too fast, by the way. And then we need to register that state. Walking forward callbacks. We call it walking forward. And then, is that all we need? Okay, so maybe this will work, unless I forgot something. Okay. So what do we forget? Nothing's happening. I mean, the character's moving, but we're not printing out state changes. So what happened? First of all, I want to get rid of this, but so we did record this. Did we set up the context correctly? That's the question. Oh, yeah, I forgot. We need to copy the input command to the context. So we'll do that in our... Let's do it here for now. Well, we'll go ahead and... Actually, we'll just make a new system for it. Our input command system. Input command. And for now, we're just going to copy over input. From the first player input to our first player state machine, each frame. So let's see, it needs to be in the context, right? So context dot input command is going to be equal to this. And this, when you make this the first thing we update in the game state. Okay. Okay. So is that going to get us what we want? So if I press the button, you can see it says goes from standing on end to walking on start. I release. Go from walking forward on end to walking on start. So that works. Cool. So other thing we want to do is we could add more states really quickly, but I do want to demonstrate adding more things to the context. So right now we have this code, right? This should really be something we do in the state, right? So let's get rid of that here and move it to a walking state, for example. So when we're walking, we'll do this. We go to common states. When we're walking, we'll change the velocity, right? We'll update the velocity. Don't need this at all. So we need to add a physics component to our context. So for now, what we're going to do is go to our initialization code and yeah, we need to set up the context to equal. Oops. So actually we need to add. So what we're going to have to do is go to our context real quick. So the context doesn't have the physics component reference yet. So we're going to do these things in a better way eventually, but this is more demonstration of concept I'm trying to get across. Okay, so we don't have the physics component, and unfortunately the physics component is part of the game's simulation module at the moment. So we're going to have to break that up. So what for now, let's see, this is going to be... So one thing we could do is we could just have this as a variable that we copy back over, but the question is, do I want to keep a reference? So for now, this is like a demonstration of something I wanted to do anyway, but yeah, so for now, let's make a new file. New file. Call it components dot zig. Okay, it should be in the source file. Okay, and let's do this. Make a pub. So we're gonna move the physics component here, And let's just for, I don't know, let's just get rid of the S on the here, so that, anyway, yeah, let's just name this the component.zig, and then like in our game simulation, we could do something like const component equals import, import component.zig. So we have this component module, and instead of having physics component equals here, we can replace everything with component.physics component. Or you have the type referenced. Okay, so now we could actually import that into our state machine. So let's do that. So we have access to all the components, right? So we can import .zig, and then we can have our physics component equal to physics component equals defaults. Great. So we have that in our context now. Well, we don't actually want to copy necessarily. That's going to be expensive potentially for any like large number of entities in the future. So for now, let's just make our physics component a pointer. And it's going to have to be an optional pointer, right? So I think that was the syntax. Is yeah. And it's going to default to null for now. Okay. And then within our main game simulation here, we're going to have to it's going to equal to our self.physics, physics components 0. And that's going to be equal to this. Okay. So we have our physics component available to us here in our context. Now we can go back to our states, common states, and so we have this code, right? So what we can do is if context.physics component, we'll capture the physics component in this variable. I think we have to make it a pointer so that we can actually make changes to it. Otherwise, it's going to be const. And instead of this entity thing we're doing here, we don't do anything like this. So we're not doing this stuff. We're just doing this. So we're going to be moving right, but 1 unit at a time. Let's just make it a little faster for now. Okay. Okay, we should be able to up the velocity here. This is just like a capture syntax for Zig with and this is an optional. Okay, is that gonna run? No, got an error, of course. It's fine. Use undeclared identity for math. Oh, I have to include math. Sorry. Oops. That is it. Yeah. Okay. Import math equals. What's the syntax again? Oh. Const math equals import utils slash Okay. What? There again. Starting but does not support field access. 46. Okay, hold on. So that doesn't work. I don't. Does this give us? So is it just this? It's not constant. My assumption was Zig. Everything just ends up being constant anyway. So maybe that works. So if I press right, it works. They start moving. When I release the button, it doesn't stop moving. It's because I haven't set up the velocity to go back to 0 on the standing state. So on standing, we have to do something similar, right? So for now, we'll just do it every frame, just in case there's any kind of like impulse or velocity applied to the player. I don't want to do that. I just want to copy the physics stuff. Okay. Okay. So let's stop character movement on standing. Okay, and this is gonna be 0. So that should work. Press right. As you can see, press right and release. We have our state machine. Now it's controlling the character. I could spend time going through all the states that we could implement, like attacking, jumping, and stuff. But we're at like an hour mark, and I think we hit a good stopping point with demonstrating how the state machine can be used to control a character. So next time we'll go through. I think what we'll do is handle. So let's go ahead and put it in our agenda real quick, just so I remember. Let's not forget these things. Okay. See. Okay. So next time we'll implement more character states. And I think we want some form of like, we don't want these global variables sitting around with like the states. So we're gonna want to have some kind of persistent data for the character. So implement so we need some kind of like constant data that's not part of this game simulation state, such as those state machine references to on update, etc., etc. In the future, we'll add like hitboxes and stuff that as well. Okay, so that's that. I don't know if anybody has any questions or anything like that. I'll try to get this video out on YouTube as soon as possible and then commit these changes. Yeah. But yeah, that's pretty much it for today. If there's anything else, just let me know. But yeah, we're about an hour and 8 minutes here, so time to about call it so I can get to work on my day job. So cool. Well, thanks for everybody coming by. As always, really appreciate you having come watch my stream, because talking to the air and getting no response is not that much fun. All right. I hope you learned something. I hope this is helpful at all. We'll be making improvements over time. I like to start with like conceptually, like this is how it's going to work, but then we can like optimize and reduce potential bugs by changing the architecture a little bit over time. So, well, anyway, yeah, again, thanks for dropping by. I hope you all have a good night, evening, morning, wherever you may be. Enjoy the rest of your day, and see you soon. Goodbye.